In this demo, we will learn how to create a JSON Web Token. ASP.NET Core includes a set of classes we can use for that. But first, let's create a controller and endpoint to generate the token, as we learned on the slides. So we add a new controller. It's an empty API controller, and we'll name it Authentication Controller. As mentioned while explaining routing, I'm not a big fan of automatically inputting the first part of the controller name here. So I'm going to be explicit about this. And then we're going to add one action to it. We'll name the action Authenticate. The idea is that it will return a token, which is essentially a string. So an action result of string as the return type is what we need here. The HTTP method, as learned on the slides, should be POST. Username and password are sent over via the request body, so we need a class to hold these. This is a class that will not be used outside of this controller. We can add it in a separate file, but we can also scope it to this controller namespace and even define it inside of its class. There we go. Of course, if you prefer, you can still separate this out to its own namespace or even file. That authentication request body is what we accept as input. As we learned, it will automatically be deserialized from the request body, as a class is a complex object. The first thing we want to do in this action is validate the credentials. Let's add a method call and method for that. So the method will be named validate user credentials, and it accepts the username and the password. Then it's time to implement this method. The first thing we need is a type to return, some sort of user. Object isn't going to cut it. So let's create such a user class that holds a bit of information about the user. This too is a class definition that can be scoped to the current namespace, as it's not going to be used outside of it. So that's exactly what I'm going to do. It's a very straightforward class. CityInfoUser containing a few properties and a constructor to construct it. It contains a user ID, which is the unique identifier for the user, a username, first name, last name, and city, all claims about the user. We also add a constructor to make it easy to construct this user. And this is the type that we're going to return from our validate user credentials method. In real life, your credentials are probably stored in a table in your database or in a separate user database. We don't have a user database or table, and it's a bit out of scope for this course to start creating all of that. What's important for us is learning how to generate the token. So what we are going to do is assume that the credentials are valid and return a user. If you have such a user database or table, check the pass-through username and password against what is stored in your database. Back to our action. If no user is returned, that means that the credentials weren't valid, so we return an unauthorized. Otherwise, we can continue with creating the token. As we learned in the previous clip, tokens are signed, so we need a key to sign with. Keys are created from secrets, so that is what we must store. As you remember, when we stored the connection string when we learned about Entity Framework Core, you should store these types of secrets in a safe place when going to production, like in a key vault. But seeing we're developing, we can store them in the development app settings file. Let's add an authentication element and a key value pair for the secret, which we'll use to generate the signing key. While we're here, we can immediately add two other key value pairs. The issuer value, which is the entity that creates the token. In our case, that's our API. And then the audience. Audience is the entity for whom the token is intended to be consumed. As we learned on the slides, the token is intended to give access to our API. It's thus at level of the API that it will be consumed. So the audience value is CityInfo API. Note that this is a string that we can choose, so we can give it any value we want. But I prefer to be clear about this. Alright, back to our code. We need to be able to access configuration values, so let's inject a configuration object. We do that via constructor injection. This isn't the first time that we've done that. And let's store it in a private field and add a null check as we're used to by now. Alright, now we need to create a token. We use the secret to create a key. For that we new up a new symmetric security key. That's defined in a package we don't have yet. Microsoft.identitymodel.tokens. We could now use the NuGet dialog to search for this package. We could use the package manager console and call install package there. Or we could use the CLI and install the package from the command line. But what you see here is a fourth option. We can use one of Visual Studio's built-in IDE features to automatically install the package. Let's do that. And there we go. To new up such a key, we need to pass through the secret as a byte array. So we get the secret from the configuration file, and then we use encoding.ascii.getBytes to convert it into an array of byte. Encoding is defined in system.text, so we need to import that namespace. From this moment on, we have a symmetric security key, but we don't have signing credentials yet. Signing credentials are, as the name implied, the credential that will be used for signing the token. We can new that up by passing through the actual key used to sign and the algorithm. SHA-256 is a widely used standard at the moment of recording. And with that, we've got our credentials to sign. Now on to what will be in the token. A token can contain information on who the user is. These are key value pairs which we call claims. A claim in this context is thus identity-related information on the user. So we create a list of claims by newing up a list of type claim. Claim is defined in system.security.claims. Sub is a standardized key for the unique user identifier. We can give these claims any key we want, but I prefer to follow standards when they exist. For first name and last name, the standard claim types are given name and family name respectively. And lastly, we add the city. From this list of claims, we now need to create the actual token. For that, we first new up a JWT security token. This too is defined in a package we don't have yet. We can install it via the UI. Package is named system.identitymodel.tokens.jwt. So we new up a JWT security token. We pass through the issuer and audience values. We just detailed those when we put them in the app settings file. Then we pass through the claims. The two other values are two datetime values. The first one is a value that indicates the start of token validity. In other words, before this time the token cannot be used and validation will fail. The second one is a value that indicates the end of token validity. After that time the token is invalid as well. And the last parameter we pass through are the signing credentials we just created. To effectively write the token, we new up a handler and call writeToken on it. We pass through the JWT security token we just created. This results in the token string, which we can then return. And there we go. That's our method to create a token. Let's give that a try. Let's build and run. And let's switch to Postman. I've got a request lined up here. Post authentication info to get a token. We post to the newly created endpoint and I pass through a username and a password. Let's click send. And what we get back is a token. Let's copy this value and let's have a look at what's in there. Let me paste that in here. And there we go. Our decoded token. Tokens consist of a header, which can contain information on the algorithm used for signing. The second part is the actual token payload and the last part is the signature. We learned about that on the slides. The reason why I can just copy paste this token here into jwt.io and have a look at its contents is because tokens are not encrypted. They are only encoded. That means that token-based security, at least out of the box, relies on HTTPS for encryption. So that is very important when working with tokens. HTTPS is a must. So we've got our decoded token here. In the header, we can find the algorithm used for signing, which matches what we passed through when we newed up our signing credentials. Then we see the list of claims we added. And we also see an NBF, which is not before, and EXP, which is expires on. These are dates in Unix time format. So these are the amount of seconds passed since January 1st, 1970. We also see the issuer and audience in the token. And lastly, we have the signature. So with that, we've got our token. Let's continue with the next demo.